Hi, this is David Yak. Welcome to the third module in the video series. In the first module, the Overview module, we covered a high-level overview of the Power Platform and some of the capabilities you can do from top to bottom. In the second module, Tailoring, we looked at how you can tailor the Power Platform, build applications, build flows, and really make it your own, matching your requirements. If you're just joining us now, you might want to consider going back to either the overview or the tailoring if you haven't watched those, as they set some of the stage for what we'll be talking about here in the third module on extending. In this module, we'll be looking at some of the techniques developers can use to unblock complex requirements encountered with building some of the low-code solutions that we talked about in the first two modules. In this diagram, we take a look at some of the common data service extensibility points that you can leverage for doing integration or extensions of the platform. Extensions was thought of at the heart of the architecture of the common data service, allowing you to implement your custom code at the lowest levels, integrating with the API as part of the platform services. You also have the ability through client extensibility to build custom components, as well as use the client API to implement form event scripting that we'll be talking about in this module. Let's start by looking at client extensibility, and here we're really thinking about things that make it a better user experience for the user, implement business rules to kind of keep them within the guardrails that the organization needs to implement for the solution. And this starts on the left-hand side with customization. When you're actually creating attributes and entities, you actually have some ability to do some of the validation and rules within the configuration of the attribute. For example, making a field required or not required if it's not conditional. You can also make ranges, so if a field needs to be between 0 and 10, you can put bounding ranges on the min and max values. And all that can be done with configuration without even getting into a business rule. And then kind of the next level of sophistication gets into business rules. We saw an example doing that in the tailoring module, where I created a business rule that when you checked the fee waiver, it made the fee no longer required, and when you unchecked it, it made it required. That was done by a business rule without having to get into deep code, or it was all declaratively done and described declaratively in the designer for the business rules. From there, we move into the third box, which is web resources, client API, and JavaScript. And effectively, that's where we transition from low-code approaches to more high-code, more traditional development techniques. Web resources have been a staple of the platform for quite some time and are being replaced by custom component. We'll see that shift happen as the custom components take on more of a role in building out the custom user experiences. But web resources are still viable today. They're essentially just an HTML web resource where you control the content in it. It doesn't have a contract with the hosting form. It's very much just a hosting of the HTML content that you can use pretty much whatever frameworks you want within the canvas that web resource has. The client scripting API works with JavaScript to implement event scripting based on events that happen on the form. Effectively, it's the way that you implement business rules in a more code-first approach. And I'll talk a little bit more about the client API and some of the event registration as we get a little further in the module. The final box is PowerApps Custom Component Framework Components, or custom components. These are kind of, I like to think of them as the next generation of web resources. They're a little bit more sophisticated, while they still allow custom creativity within the canvas that you have using the frameworks that you like. They have a more defined interface with the hosting form that makes them a little bit more structured, and they're also able to be configured a little bit easier by somebody using them, not only in the model-driven app, but also in the Canvas app as they're hosted as the custom content. And we'll look at these a little bit deeper as we get a little further in the module. Let's take a little deeper look at the client API for JavaScript. This basically allows you to interact with the hosting form. Essentially, what you're implementing is business rules, but you're implementing them in code. And an interesting side note that you might be curious about is if you actually looked at the internals of the business rules like we built in the tailoring module, it uses this same client API for the business rule when it runs in a model-driven application. Now, the real purpose of the client API is to abstract you from having to have detailed knowledge of the HTML structure that's rendered for the form. That keeps you abstracted and allows them to change the internal renderings, and that's actually happened a few times over the years, and by using the client API, you're completely shielded from that. And that's why one of the things you want to really think about using the client API for is essentially to implement business rules. It's not to implement a custom user experience or to change the visuals. as much as it is to interact with the controls that are already on the form, make things required, not required, validate data, preset some values, any type of business rule type things. And where you want to use this over the business rules that we used in Module 2 is when your logic needs to get so complex that it's not possible to be written in a business rule. When you use the client API for form event scripting, you're essentially creating a function that's going to handle an event, whether it's the save, the load, the on change of a field. It's going to get called in reaction to that. And in fact, on the next slide, I'll talk about how you actually register this function. In this example, we actually created a function. That function is going to be passed the execution context. That allows you to get the form context. If you remember on the last slide, that is the entry point to the client API. From there, you can call other functions. In this example, we're using the form context.ui.setFormNotification to put up a notification message, and then we're going to let it sit there for 5 seconds and then remove it. So it would be just kind of a brief notice when they came on. This is not going to do anything just by creating it. So we would actually upload this as a web resource, and then we would register that against the onload for a particular form. To allow the function that we showed on the last slide to be executed, we have to register it on the form. So if we go into the form properties, we would associate our code library to it. So the JavaScript that we uploaded that would have that function. We would then register an event handler. So in this example, I'm registering an event handler on form onload, and that would tell it on load of that particular form to run that function. If you have 5 forms, 5 entities, you'd have to register that on each of them. That informs it which form to run that particular function on. And then that function would be invoked as the form loaded or on save, depending on which handler you registered it with. Before we talk about the PowerApps component framework, I wanted to introduce you to one of the tools that we'll be using in building the PCF components, and that's the Developer Tooling Command Line Interface, or the PAC command. This essentially is used as part of tooling for the PowerApps component framework. It allows you to initialize the component, so essentially templating out some of the initial pieces of the component that you're going to build, allowing you to jumpstart that activity. It's also used in the validation and build of that component to package that up as a solution to be able to be imported into the system. Currently, the CLI is targeted only for the PCF use right now, but it will evolve to also support plugins and web resources as we talk about them later in the module. You'll see this over time become the all-encompassing tool for doing some of the developer tooling from the command line interface. PowerApps come out of the box with several standard controls or components that are used to visualize data, input data, and interact with the user. Examples are simple text box labels, even the grid that you see a list of data or the layout control. And what the PowerApps component framework does, or PCF as it's known for as a short acronym, allows you to build custom visualizations for those fields instead of the built-in control types. These are built using traditional developer tools, but once they've been built and imported into a PowerApps environment, they can be used in a PowerApps Canvas app or model-driven app by being configured as a control to replace the existing controls. So for example, the field controls tie one-to-one with a field on the form. Data set controls are intended to work with a set of data, so you might replace a traditional grid that just lists the data with a calendar more visually showing the events based on the start and end date that the events have. And then unbound controls, which are supported by the platform but are not readily yet available for third parties to create. They're only used by some internals, but they will be coming soon. They allow you to do things like a map or other visuals that have no tie back to a specific field, but are used in the context of the form or other places that components can be used. I wanted to take a second to illustrate an example of a before and after with kind of an extreme example of using components on a form to just really drive home the amount of change that you can do by replacing or reconfiguring custom components on individual fields and other components within a form. This is a sales opportunity. So this is, they're selling 4G enabled tablets. And you'll notice it's a very textual focused display. Not a lot of eye candy on there. And then if we look at the transformation that this has by replacing a lot of things with custom components, we can kind of see where you can plug these in and the radical transformation you can have on the user experience. And here's what it looked like after. Obviously, they've configured quite a number of custom components on here. You'd probably be more, practical of how you use it on one or two places on a form. But this illustrates that you can kind of have a very visual difference in the before and after by bringing in some a little bit more eye candy, something a little bit more visual. Oftentimes, the components can be used to give a little better interaction. They can be a little bit more touch friendly than you might find at just a simple text box if you have users on the go. And that's just a look at a before and after, so you can kind of see what it looks like bringing in some components. So let's talk a little bit about what makes up a PCF component. At the heart of it, you have a manifest file which basically describes the control itself, the name, the version, the properties it uses, and any resource and files that are there, which includes the implementation files as well as resource files like CSS and other localization files that you might have. You have the component implementation itself. So this is where you're actually writing the code. Components can be built using either TypeScript or JavaScript. Now, as you probably are familiar, if you do use TypeScript as the language that you're coding in, it transpiles down into JavaScript. So what ultimately gets uploaded to the PowerApps environment is the JavaScript that implements the component. Now, also included in this is the resource files. So if you're using any CSS files, you're doing localization, any images you need to reference, those all get packaged up. And what happens with the command line interface tool is once you're ready to build this, it'll package this all up as a solution file. And that solution file will be imported into the target environment, making that control available for configuration on a form. Let's go ahead and jump in and create one of these components and take a look at the code that gets generated by the command line tool when we initialize one. Okay, I'm here in the developer command prompt, and all I've done so far is I've installed Visual Studio Code, I've installed the Node Package Manager, and I've installed the PowerApps command line interface tools. What we're going to do now is use the tools to initialize a component project. We're going to then build out a component. Our component we're going to build out is a markdown viewer. So we're going to basically put a replacement control on a text area that will allow us to input markdown and then view it as HTML. So I'm going to start the process by pasting in the command pack pcf init. What this does is initialize a project template for building a PCF component for a field template type. And I'm going to call that markdown viewer, and I'm going to use MDV as the namespace and the field template. Now, we can do a quick look at what's been created. We'll see that there's been several files created. And if we look at the markdown viewer folder, we'll see that that's where the main file, the index.ts that we're going to build our code in, and the control manifest, and we'll actually look at those in a few minutes. Okay, what we're going to do now is we want to create a folder to store our solution. And in that folder, we're going to use the pack solution init command to initialize a solution template that will package our component into when we do our build. We're going to use a customization prefix of MDV and a publisher name of CDS Tools. And if we do a quick directory on here, we'll see that it's added a few things. And if we look at the other folder, we'll notice that this has kind of the baseline of what will go in the solution. Our component will just be added into this packaged up for distribution. But before we do that, we need to do one more command to associate our component with the solution template that we just built. And we're going to use the pack command with the solution add reference to pointing to our component source folder to do that association. Now you only have to do this once, and that sets it up, and then when you do the build, it's all ready to go. Now what we're going to do now is go back to our source folder, and I'm going to open this up in Visual Studio Code, and we'll take a look at what we've got. Now if we look at what has been built, we'll see node modules. This is just the dependencies that have been added. We'll see our project files. These are used by the task runner, both npm as well as ms build. And we don't have to do a lot with those unless we want to customize how we're building some of the stuff. Where we spend most of our time is in the actual source folder, the markdown viewer that was generated. And we'll start with looking at the control manifest. Now this is what defines what gets packaged up as part of our control. And you'll notice that it sets up a default property for us called sample property. We'll be replacing that in a little bit. This is where you add any of the properties that you want to reference and be configurable by the maker when they use the control in the app when they build it and replace a field or a data set with that. You have all your resources. So these are all the code files. Right now we just have index.ts. That's our TypeScript file that all our code is in. You can have multiple files. You can reference other libraries. You can also reference style sheets as well as resx files, which are used for localization. And we'll actually set that up and pull in some of our display names from that, making our control ready for localization. And if you're using any of the special features, things like the device capabilities, the utility namespace, or the web API, then you would uncomment this and you would enable those features in there. The main work happens in the index.ts that's generated. This is the class file that has the code that we'll be replacing or adding to build out our component. It is prescriptive by the component framework. You'll notice it has an init that gets called when the control initializes on the form. It has an update view that is called whenever the control needs to update the surface, and get outputs to get the results from the control to bind back to any of the data that is the control is connected to. And we'll be actually working with those functions when we build out the control in a little bit. I'm going to start by go ahead and building out my resource file. So I'm going to bring out the resx, and we're going to use localization. I think that's one of the best ways to kind of build things out. I'm going to copy this name. This is the strings folder. You can provide one of these files for each language types. We're just going to go ahead and provide the primary one, English, right now, and we're going to put it in a strings folder, and I'm going to create a new file. And what this is used for, you'll see when we reference things in our control property, what we're able to do is basically replace this with a localized version. And most of the stuff at the top of this is all just boilerplate. You don't have to worry about it. The ones at the bottom here, for example, the markdown display key and markdown description key, these are the display name markdown text, and this is a markdown text. That's the description for our component. And if we did one of these files for each language, that would localize it. And when we package this up, the control manifest points to that. So now we have that all set up. Now the next thing I want to do is replace the sample property that we have on here with one that is more meaningful for our own. And so with that, I'm going to go ahead and replace it with a property name markdown text. And you'll notice for the display name key and the description key, I'm referencing our resx file, our language key that we set up. And that will always pull from the current language. We're using the type of multiple. This allows multiple lines of text. It's a bound, so that means it'll allow it to be bound to one of the fields. And it is required. So when you configure this component into the maker experience, the maker will be required to provide a value for this item on there. Now we can move over to our code. Now, one of the nice things about the component framework is you don't have to build everything from scratch. A lot of what you'll be doing with the component framework is wrapping around existing functionality or existing libraries or existing component that you want to surface in the PowerApps environment. And that's exactly what I'm going to do here is I'm going to use an open source library called Showdown that basically is able to take Markdown and convert it to HTML. So to do this, what I'm going to do is I'm going to install Showdown, the open source library we're going to use via Node Package Manager. I'm going to do the npm install Showdown. That will bring it into our project structure. The other thing I'm going to do, because we're building in TypeScript, is I'm going to add the types file for the Showdown project, and that will allow me to use it nicely from TypeScript. Now, from the top of my index.ts, I want to go ahead and import that Showdown component in so I can use it later in the code. I'm going to add a couple of class level variables to track the HTML elements that I'm going to build and want to be able to work with. Now I'm going to add a utility method that's going to do the actual rendering by calling the Showdown library to basically do the calls. So this is going to take the markdown text as a string. It's going to do the convert using Showdown converter to convert it from text to HTML. And then it's going to set the inner HTML of the target property, which will bind in a little bit to the HTML that was converted. Now we can add the rest. The first thing we're going to do is come up to the init function. This gets called when the control initializes. And we're going to do some initialization of the HTML elements. Now this is where you could use Angular, you could use React, you could use Vue, whatever your favorite library, or you could just do the create elements like I'm doing here to kind of create a text area in a div and drop those in. And essentially we're binding the on change to our render markdown so that when the text changes, it calls the library and renders our HTML version of the markdown. So the next thing we're going to do is we're going to update our update view function and give some code there. This function gets called by the framework when any value in the property bag has changed. So if the field value, so like our text field changes, the markdown text that we were bound to, then this method will be called to basically advise us of that. And so what we're going to do is we're going to get the parameter value, the markdown text. This is showing red just because I haven't built yet. And then we're going to call the render markdown function to get the HTML set in our component. And then finally, the last method we're going to update is our get outputs. This is called when the framework wants to get the value from the control so it can bind it to the data that is on the hosting form or component. So we're going to replace this with returning our markdown text value of the converted markdown. Now that we've built our control, we can go ahead and build it. I'm going to do an npm run build. Now, if I had gotten any errors, it would tell me right there. I'd resolve them and then build again. Now I can use the test harness. So by doing npm start, we'll kick off and load the test harness. This will allow me to see the component and interact with it in a test mode. Now this is a great way to test things out before actually binding it to the real component and deploying it to the environment. You can do this interactively as you're building it. So I could just say, hello, how are you? And notice that I haven't done a lot of formatting of the control. The next thing I would do if I was building this out for real would be to style this and make them side by side with appropriate or maybe tabbed interface, however I want to do that. But you can see as I put in the markdown, it restyles it as I leave that field, just like it would as you moved out of the field in the user interface. And so this is very interacting with the component. I didn't have to build that converter to the markdown. I used a library. So the next step we need to do is to package this up to actually to be able to deploy it. And to do that, we're going to come back to Visual Studio Code. We're going to stop our running of the test harness. We're going to issue a build command. And that's going to build our solution file with our component in it from our output. Now what we're going to do is go ahead and import the solution. We're going to browse to the folder that has our output in it. We're going to select our solution file. We're going to start the import. Once it finishes, then we will go ahead and publish the customizations. We're going to switch over to the Controls tab on the editor, form editor, go to Add Controls. We're going to pick the Markdown control. We're going to see that it already configured our field Contoso description because that was the only multi-line text that we had available. We'll go ahead and click OK to save that changes and click Save and Publish on the form. We can switch back over to our Permit Manager application. We'll go ahead and refresh the form. You'll notice that we now have a description tab on there that has our markdown control on it. We'll go ahead and enter some markdown and tab out of the field, and we'll see that it visualizes the HTML version of that markdown. And that's how easy it is to build a PowerApps component framework control and replace the standard control with our own custom user experience. In the tailoring module, one of the things that I talked about was how when you created an entity that you got some of the API support without having to do any additional development. The platform has a standard REST-based API. It implements the OData V4 protocol that allows it to have a standard querying pattern for any entity that you create in the system. This API respects all the security as well as the business rules that are implemented either through plugins or through business rules that are done declaratively like we did in the tailoring module. In addition to operations against the data, whether it's querying, creating, updating, or upserting, it also provides actions and functions, or a suite of actions and functions, some that are just platform supported and come out of the box, others that are added as you add applications. Things like field service or applications you build can implement custom messages that fall into the play with the actions and functions that are available through the API. Additionally, you have the ability to work with the metadata. So for example, everything we did in the tailoring module through the portal to create entities, create attributes, and so forth can be done through the API working with the metadata directly. Using the API can come in handy in a number of scenarios that you'll encounter on projects. For example, if you were building a custom portal, you could use it to reach back into the CDS data. If you were building an Azure function to offload some of the processing, you could use that to reach back again to the CDS data. You could use it for any integration because it's an open standard-based endpoint using any of the libraries that can talk to an OData version 4 endpoint. You can interact with it from any of the languages of your choice or techniques for development that you want to apply. Now let's talk about one of the deepest extensions that you can do of the platform, and that's build a plugin that plugs into the operation pipeline and registers to be processed as part of one of the messages the platform is processing. The best way to understand this is think about everything that is done in the platform as a request and follows a request and a response pattern. So for example, if I'm creating a record from the user experience or through the API, it's going to generate a create request. Now when that create request comes in, it's going to be processed, and then the results are going to be in the response. Now in the case of the API calling that gives the ID of the record that was created. Now, different requests have different responses, and you can also build custom messages that give your own processing where you implement the code that runs as the platform operation. As you can see on the right-hand side, I've got my create request that comes in, and as I start processing it, it goes through what's referred to as the pre-operation events. These are a place that you can register custom code. Now, what you're registering is a plugin, and I've got an example of a plugin here on the left-hand side, the very simple code. It's one method execute. That's what's required by the iPlugin interface. And that's effectively all you need to do to build a plugin is create a class that implements the iPlugin interface. That interface requires one method. That method is handed an iService interface that allows you to get information about the current request that's being processed. In this particular example, I'm simply formatting the phone before the record is created or updated on the database. This plugin actually changes the in-memory request before it is processed by the platform operation. Now in this example, the platform operation is to insert the record into the CDS database. And then once that record has been inserted, you have another opportunity to register an event handler or a plugin to process the data after the operation is completed. For example, if it was a create request and I wanted to create other records using the API from the plugin, or reach out to another system, maybe out to SharePoint to create something, a SharePoint document library for that record, I would do that in the post-operation phase because I might need that record ID, the GUID that was created when the record was created, and that wouldn't be available in the pre-operation. So in the post-operation can run real-time synchronous before the user sees the results. You can also, when you configure the event handler, the plugin, you can designate it as running asynchronous, which means that the user will still get response, but your plugin will run asynchronous to that happening. It probably goes without saying, but because plugins are so tightly integrated with the platform operation, you want to make sure that they're used as judiciously as possible and are very efficient with any processing that they're doing. This is not where you'd want to have any lengthy processing happen. Let's jump in and look at the code in a little bit more detail and see what type of data is available to that plugin. Okay, I'm here in Visual Studio and I want to take a look at the plugin that I've created and kind of walk you through what it's doing. It's a very simple plugin meant to do some very basic formatting or essentially removing some of the characters from a phone number so that you just have the number portion of it. But I want to demonstrate how to actually build a plugin. The key thing that you have to do when you're creating a plugin is you have to create a class that implements the iPlugin interface. Now, if we actually drill in and look at the definition of this, this is a very simple interface. It requires you to implement one method, execute, and that gives you the iService provider or the service provider property as input to that you can use to get other environmental information on there. And in fact, that's what we're going to do. You'll notice that what we're doing is using that service provider to get the service. And that service that we're getting, one of the ones you can get is the plugin context. You can also get an organization service, so if you want to do API calls. But this plugin execution context is really where you get all the valuable information about the requests that you're doing some work on. So if we drill into that and look at the definition on that, we'll notice that it actually implements from iExecution context, which has the real meat of what we're going to get handed to us. So we drill down a little bit deeper. And you'll notice this is where it tells you if you're in a transaction, if you're executing offline, a correlation ID, which is unique to the request. But most importantly, it gives you the data that is being processed on the request. So for example, you get the primary entity name, you also get the message. So in our example, we're going to register on create. So the message name would be create. The primary entity name, we're going to register on contact. So that would be contact. Now, the other key thing that you get from this is the input and output properties. So in our case, this is going to mimic the request that was made. So on an update, it's going to be in a target parameter and it's going to have the attributes of the entity. We'll see it just contains the values that were provided on the screen. If you were registering this in a post operation, in other words, listening after the record has already been created, the output parameters would have the output from that request that was being processed. So if we go back and look at this real quick, we see that we basically get the context. We check if there's a target property in the input parameters. We get the input entity from the input parameters. We get the phone number if it's available, so we check if it's there, and then we do a simple regex to remove any special characters other than the numbers that are in that. And then we update the in-memory version of that request. And because we're going to run this pre-operation, we're actually able to modify the request for the platform operation before it actually creates the record on the database. So let's go ahead and build this real quick. And then what I'm going to do is go ahead and register this with the plugin registration tool. So there we have it built. Now I'm in the plugin registration tool. I've logged in, I've connected to my organization that I'm working with, and you'll see that I have a list of all the existing registered plugins. And this includes some of the system ones that are there that you don't really need to do anything about, but they use the same capabilities that I'm using to hook my logic in. So what I'm going to do is I'm going to go ahead and do a register. I'm going to register the new assembly that was built. I'm going to browse to the output from that project, pick my assembly that was created, and you'll see that there's one class, format phone created, and it recognizes that as a plugin because that class implements the iPlugin interface. So you're only going to see the ones that do implement that interface. Now once I register this plugin, I'll be able to actually register steps against this. So you'll see that it has created, and then what we're going to do is we're going to go down here, and in the list, we now can expand it. We don't have anything registered, so we're going to right click, register new step. Now this is where just uploading the assembly doesn't actually hook it up to any events that happen in the system. So what I want to do is go ahead and hook up to the create event of the contact entity. And I want this to run in the pre-operation stage, and I want it to run synchronous, meaning I want it to happen before the platform operation. And I need that because I'm actually updating the in-memory version of it. Now once I go ahead and register the step, that's actually active in the system, and any new contact that we create in the system will go through the logic that I just uploaded. Now let's switch over to the app and take a look at creating a record and seeing it do the work on our behalf. Okay, let's go ahead and create a test contact so we can test this out. And what I'm going to do is for the phone number, I'm going to put in 719-555-1212. And you'll notice that I've got the dashes in there. Now what I'm going to do, and in fact, let's go ahead and just add some more formatting in there. In fact, we'll just leave it on the beginning. And what we want to do is make these phones all consistent, so it's going to run our plugin. And when I save the record, what we're going to see is that it's going to strip all that extra stuff out. What we just did is we ran our logic, it processed it, it updated it before it created the record, and that's what you can do with plugins. Another powerful capability that the Common Data Service has is to publish events externally for processing by other systems. This can be used for integration scenarios or simply to offload work that you'd rather do instead of in a plugin in some other things such as an Azure function or a service running in an Azure virtual machine, or your other favorite cloud provider for that matter. The first four of these, relay, queues, topics, and event hubs, all publish out to Azure services. Webhooks is just a generic post out to anything that's listening using the standard webhook syntax for being able to publish it out. And that means that you could effectively have a web API running on your notebook as long as it's public addressable that webhook can post to. Obviously, I wouldn't recommend that for a production one, but there are also more robust things that you want to do. Queues is probably one of my more favorite ones for integration with the Azure Service Bus queues, because this really allows the two parties to be decoupled, basically bringing an event out of the Common Data Service and posting that into an Azure Service Bus queue. That queue can then be picked up by a listener, do the processing, and you could use the API to reach back and say that you've completed the processing, or however you want to deal with the communication between the parties. Now you configure this by kind of a two-part configuration. The first is you define the service endpoint. And each of these on the right-hand side, the relay, the queues, the topics, event hub, and webhooks, all are configured as service endpoints. And then essentially what you do, just like you're publishing or connecting to a plugin or registering for an event in a plugin like we saw in the last demo, what you're going to do is effectively do the same thing, but instead of hooking up the plugin, you're hooking up to that service endpoint. And the same thing that a plugin would get, a copy of that is published across to the remote listener. Let's go ahead and take a quick second to see what it looks like to configure to publish to an external webhook. I'm here in the plugin registration tool and I've connected to our environment. And what I want to do is go ahead and register a webhook to publish updates on permits out to an external site. So what I'm going to do to start with is I'm going to go use the site to be able to do this. I'm using webhook.site, but there's a number of sites that you can do if you want to test this. or even better, hook it up to a real webhook. So what I'm going to do is go ahead and grab that URL that it wants me to post to. I'll go back to my plugin registration tool. I'm going to come up here and register. Now there's two ways that you can register to have events published out. You can register a new service endpoint, which is what's used if you're publishing out to any of the Azure resources, or you could do the one that's specific for webhooks, new webhooks. Now under the covers, they're both types are stored as service endpoints, but I'm going to go ahead and create a webhook. I'm going to call this permit updates, and I want to give it the URL that I want to post to. You can give it the authentication style that you want to use. Now we're just testing, so I'm going to use the webhook key, but you could use whatever your web service requires. We'll just put in a test permit as the value and save that. Now at this point, we've registered the webhook, and through code, you could actually publish directly to this endpoint from like a plugin, for example. Now what I want to do is I want to enable automatic publishing of events. So I want to publish anytime that there's been a create or update, I should say, happened on the permit entity. So I'm going to register a new step. I'm going to choose update as the message, just like we did when we registered a plugin and we wanted to hook up to the event. I'm going to pick Contoso permit as the entity. Now you can choose, because it's an update event, you can choose to have filtering. What filtering does is ensure that you don't get triggered by attributes that you're not interested in. So for example, I'm really only interested in if the fee changes. So that would be what I would select. So if somebody changes the name of the permit, I really don't need to get notified of that, only if the fee was changed. So I'll go ahead and do that. And then I also want this to run asynchronous, and I want it to run post-operation. So meaning after the work has already been done, go ahead and publish out to me to tell me, because I don't need to be part of the transaction that's happening. So we'll go ahead and register the step. And now at this point, we've created the hook to say, hey, anytime there's been an update, publish it out to this webhook. Now what I'm going to do, you'll notice the website is waiting for the first request. So what I'm going to do is I have a permit up here. I'm going to go change the price of this permit to be $5,300. We'll make a lot of profit on that. And I'll go ahead and save that. And now you'll notice what happens is fairly quickly, I'll see that show up coming across and publishing to my webhook site. And now that we have our request in here, we can see that we've got posted to us from the environment. Now what I'm going to do is go ahead and copy the JSON that got posted to us, and we'll bring that over into a JSON viewer to make it a little bit easier to read. And you can see that we've got basically the same thing we get in a normal plugin that runs in the context of the transaction, but this is now what's published out onto the remote system. This is the same as if you use this Azure Service Bus or the queues, any of the Event Hub as a publishing endpoint. You would get the same type of data. So you'll notice that in input parameters, we have the entity that we got posted, and we have the attributes, so we can get all the way down to see what data was there. You'll see the Contoso fee, and as a value, in this case, I updated it one more time to 5301. And that essentially shows what has changed in that record. Now you can also add pre-images and post-images. So pre-images allow you to get the values that it used to be. So like if this used to be $300 and it's now 5301, I would get both values in what got posted to my remote endpoint. So this is a great thing to be able to use for integration with other systems or to offload some processing from your CDS environment. While the Power Platform has over 250 connectors that are currently available for use, there are new ones added all the time. You may find scenarios where the particular service that you're working with, or even your own API, doesn't have a connector that you can interact with it. And that's where custom connectors come into play. Custom connectors allow you to define to the platform APIs that are available for use, and then once defined, they're available for use by either Flow or a Canvas app for implementation. Once the custom connector is configured, it looks just like any of the other connectors to the Canvas app or Flow that's using it. If you already have the API, you can simply configure the custom connector with a definition either through a Postman collection that you've gathered. Using the tool Postman, it allows you to run sample calls to that API, and you can save that and then use that as part of the import to define the definitions for how to invoke it. You can also use the Open API definition format, which is a standard-based format that can be used to describe the functions that a custom web API or an Azure function offers into the environment. Some of the Azure services like Azure Functions also offer the ability to help you import that in and quick create the custom connector for you. Let's take a quick look at creating a custom connector on the platform. Now in this demo, I'm going to set up a custom connector to call out to a QR code generator, and I'm going to add that into our inspector app so you can kind of get an idea how easy it is to use it. I'm going to start in the Maker portal, and I'm going to go down to custom connectors. Now I'm going to create a new custom connector. I'm going to create from blank. We're going to call this QR generator. Now I've already built my Azure function, so I'm going to go ahead and drop that in as pre-built Azure website, and I'm going to have the API base URL be just simply API. I'm going to move on to security. We're not securing our QR code. This is where if you were securing it or it was a secured API you were calling, you could choose whether it's OAuth, API key, basic authentication, and then kind of go configure it for the appropriate authentication means. But our QR code generator, we're comfortable with anybody being able to use it. Now we're going to move on to the definition. Now there's three ways that you can get the definition. You can manually create it, you can import it from a open API file, or you could import it in from a Postman collection. The latter two are the easier ways to do it for more sophisticated APIs. Ours is pretty simple, so we're just going to go ahead and manually add it. We're going to click New Action, call this QR code, generate QR code. QR code 64 is the operation. Now we need to give it a sample to be able to make it so it knows how to call our function. So we're going to use this import from sample. We're going to do a get. We're going to provide the URL to example of calling our function. We're going to import that. So that tells it how to call the function. Now we need to give it a little bit more information about what we expect to be returned once it's called. So we're going to come down to the response. We're going to click on the default. We're going to do the import from sample. This time we're going to paste in our own output JSON that we would have got back from the function. So image, sample, and then we're going to import. And now what we've done is we've defined how to call our existing API and what we expect back from it. So we're ready to go ahead and click the create connect. Now our connector's been created. It's time for us to test it. We can do that all within the portal here. We'll go ahead and click new connection. This creates an instance of the connector with our account. Go back into custom connectors, edit our connector, go back to tests. We now have our instance configured, and we can now go ahead and test our connection. We'll just say building 1, 2, 3, 4, test operation. Now it's going to call out and give us back a QR code, and we'll be able to see the results from that execution. Okay, there it's finished. We can see we've got a result back. It's 894 bytes long. We can see what image, it's a base 64 image. Not very exciting from here, but now let's go use that in our application. So I'm going to go back to apps. I'm going to edit our inspector app. First of all, we're going to go to view data sources. We're going to add a data source. We're going to use our QR code generator. Now it's associated. Now we can use it from here. So we're going to go on to our second screen, inspection details. We're going to go to insert media. We're going to put an image, drop that down over here. And what we're going to do is we're going to go ahead and replace the source for the image of that control we just added with a call out to our QR code generator, binding it to the gallery selected name, and there's our QR code. So that's a very simple way of basically defining a custom connector to our existing API. Now we obviously could have built the API using an Azure function, just a standard ASP.NET Web API, or anything that could respond to that REST GET or POST that our action interacted with. The custom connector just defines how we call it and what we expect to get back, and makes that definition available for a maker to be able to use that without having any knowledge of the implementation of that custom component. Now we talked about how you can publish things out to Azure, but I wanted to come back and mention Azure one more time as a very viable way to deal with anything that you run into that you can't do in a low-code environment. And this is, essentially true in some solutions. As they get bigger, you have needs that sometimes are better suited with more of a traditional cloud application approach. That doesn't mean that you have to abandon the low-code approach. Oftentimes these systems are better together. And you just have to be smart about how you build things. One of the things that I think developers struggle with is oftentimes they gravitate towards the lower level implementation simply because it's fun to build, but also because it's what they're comfortable with. And as a developer, you need to look across both what the Power Platform offers as well as what Azure offers and make choices for what service you should use from both of them to implement the business requirements you have. And remember that ultimately what we're trying to do is deliver business outcome. Well, that's it. You've made it to the end of our three-part video series. We covered the overview, we covered tailoring, and now in this module we dive deeper into some of the developer scenarios. We looked at some of the techniques that developers can use to unblock complex challenges that you might encounter building on the Power Platform. As next steps for developers, review some of the CDS Developer Guide. I've got the link on the slide here. But also, if you didn't listen to the other two modules, now is a good time to go back and build some of the fundamentals. Because even as a developer, you should be comfortable with some of the ways that you tailor the platform using some of the low-code techniques. After all, it is all about balancing using the right tool for the right time at the right place. Thanks again for joining us for watching this video series. I hope to hear more about what you do with the Power Platform as you continue your journey.